Hey guys, we're on to guided practice part 2. And for this part, we're not just starting in moles like we were in guided practice part 1. We're actually given grams to start with. So I'll go slowly through each problem so you can see how I go through it to get my grams into moles. Calculate the molarity. So we already know that when we calculate molarity, we need our moles divided by our liters of a solution with 80 grams of NaOH dissolved in 1 liter of solution. So the big difference between guided practice 2 and guided practice 1 is that in guided practice 2, we're starting in grams instead of in moles. So I need to convert from grams of NaOH into moles of NaOH in order to be able to plug into this equation. And I'll give you guys a refresher of how to do that. So molarity equals moles divided by liters. So I have all my 3 variables here. I know I have 1 liter, so that's easy. I can just put that next to liters, but I don't know my moles. So I can use my grams of NaOH and I can convert them to moles. So next to moles, I'm just gonna write 80 grams. And as you remember, to get from grams to moles, you need the molar mass. So this is where our periodic table comes in handy. So Na is 22.989770, so about 23. So I'm going to write that down. Na is 23 grams. And then we have O and H. O is 15.99999 or 16. And H is 1. So overall, I have 23 plus 16 plus 1. So if you can, you do it in your head, but if you want to just use a calculator, you can. 23 plus 16 plus 1 is 40. So I know my molar mass is 40 grams. So to convert to moles, you have moles at the top, and since you have grams at the top here, you want grams at the bottom in your conversion, so it cancels. So there's 40 grams in 1 mole of NaOH. So then I have 80 times 1 is 80, divided by 40. So 80 divided by 40 is 2. So we have 2 moles. So now that I have converted my grams into moles, I can plug into this equation. So molarity, which is what we're looking for, is equal to the moles, which was 2, divided by the liters, which was 1. So the molarity is just 2. So this solution is 2 molar. Remember, molar is another way of saying molarity. Make sure when you're calculating molarity that you actually use a capital M as your answer, because a lowercase m in science means meters. So like lowercase is meters, but uppercase means molar or molarity, which is moles divided by liter. So it's a really big distinction. So it actually is important that you use a capital M. Let's look at number 5. What is the molarity? So again, we're using this equation of a solution with 45 grams of C6H12O6 dissolved in 3 liters of solution. So we got our molarity variables like we've been doing. We're looking for molarity. We don't know molarity. That's what it told us we're looking for. With a solution of 45 grams, so when you see grams, you know you have to convert those grams into moles. So I'll write 45 grams next to my moles, dissolved in 3 liters of solution. So I know my liters is 3. So in order to convert from grams to moles, you need to know the molar mass of C6H12O6. So I have C, H, and O. Using my periodic table, I know that C is 12. And I have 6 C's, so I do times 6. I know that H was 1 from the last problem. And I know that O is 16 from the last problem. So I have 12 H's in C6H12O6. And I have 6 O's. So I'm going to do 12 times 6, which is 72. 1 times 12, which is 12, and 16 times 6, which is 96. And then I add these together to find my molar mass, just like we've been doing for a really long time now. So I have 72 plus 12 plus 96 for 180. So if I want to convert my moles into grams, I need to cancel my grams. So since my grams are on top here, my grams go on the bottom here. And 1 mole is equal to 180 grams. So I end up with 45 divided by 180. So let's do that. 45 divided by 180 is 0.25. So I have 0.25 moles. The next thing I need to do is plug my moles and liters into my equation. So I have 0.25 divided by 3 liters equals my molarity. So I have 0.25 divided by 3, and I get 0.08333, so 0.08 capital M molarity. On to our final problem. 1,800 grams of C6H12O6 dissolved in 20 liters of solution. So we're again going to calculate the molarity here. So molarity, moles, liters. So because I start with grams, and I know I can convert grams to moles, I just write that next to my moles so that I can later convert it. And I know I have 20 liters. So C6H12O6, we already calculated the molar mass for that in the previous problem, and it was 180. So I'm going to convert that to moles. So I put my 180 grams of C6H12O6 in 1 mole. That cancels, so I get 1,800 divided by 180. And I got 10, so 10 moles. So at the end here, I need to calculate my molarity, and molarity equals the moles divided by the liters, like we've been doing this whole time. So I have 10 moles divided by 20 liters. So 10 divided by 20. So one mistake students make is they always put the bigger number first when they're dividing. You just have to make sure you always put the number at the top of the fraction first, because that's just a common error to make. So this is 0.5 molarity, or 0.5 molar. I hope this was clear to you. Please feel free to email or text with any questions. Make sure you try your independent practice, show work, take pictures of all your work and submit it, and do your exit ticket. I hope you guys are all having a great day.